All right, let's continue this. We did up to 1 to 15 already, so now what we're going to do is we're going to start with number 16. Actually, you know what I'm going to do? Almost forgot. Let's put the test up here. Okay, now we're ready. Let's take a look at number 16. It says find x so that L and M are parallel to each other. Well, here's L, so I want to figure out how can I get those parallel to each other. Well, look at this. I know this is written really small. To tell you the truth, let's do this. Let's just kind of sketch it out real quick like that. All right. Now, if you have your test in front of you, this little angle right here is 2x plus 6, and this angle right here is 130 degrees. I know it's a little small right here, but if you have your test out in front of you, you should be able to read it just fine. So in order to make these two lines parallel to each other, what must be true about these two angles right here? Okay, they got to be supplementary, right? All right, let's try that again. What's true about these two angles right here? They're what? Right, and now they're not corresponding. They are complementary. What's the name? Do you remember the actual name? No, they're not alternate. Alternate interior is opposite sides. They're consecutive interior. It starts with a C. They're consecutive. Now, if you look at the beginning, let's not make me stop every time, please. If you look at the beginning of this test, okay, go to the YouTube video and look at the beginning. We go through and we talk about that on there, okay, quite a bit. All right, so these are called consecutive interior angles. Now, you don't really need to know the names of it to do this problem. In the first couple problems on this test, you do have to know some of those names, all right? But they're consecutive interior angles. What's true, now we've already said it, but say it again. What's true about consecutive interior angles if we have parallel lines? They're supplementary. They're supplementary. Okay, so consecutive interior angles are supplementary, which means they add up. Okay, 2x plus 6 plus 130. They add up to be what? 180. All right, and now we just solve for x and find what x is equal to. Let's do it like this. Instead of let's do it. That's 136, right? So we subtract a 136 from both sides. Would you agree? And what would that be? 44. Okay, divide both sides by 2. So x is 22. That's all there is to it. Okay, so that's number 16. X equals 22. We good with that? Make sure you know when they're equal to each other and when they're supplementary. I mean, that's the big key to this, to doing these problems. It's not really the math. It's not really the algebra. That's not the hard part. It's knowing whether to set them equal to each other or to add them up and set them equal to 180. All right, and don't just guess, and don't just. I know some people, they look at it and are like, oh, I have no clue. I'm just going to set them equal to each other and hope I get the answer. All right, look, every once in a while that could actually work, but don't just rely on that. Look at it, make sure you know the relationship between those angles. Now look at this. I'm looking at this angle, and I'm looking at this angle right here. Look, in order to make these two lines parallel to each other, in order for them to be parallel, these would be alternate exterior angles. And if these lines are parallel, what's true about alternate exterior angles? They're equal to each other, okay? They're not supplementary, they're equal to each other. So these are alternate exterior angles. It's kind of small, but this angle right here is 3x plus 10. And this angle right here is 4x minus 10. And so we set them equal to each other. All right? Do you understand that? So consecutive interior angles are supplementary. Alternate exterior are equal. What else are equal? What are some other names? Alternate interior, and there's one more. You got a bunch of you guys said it. Corresponding, right? They're all equal to each other. Okay, it's the consecutive interior, this problem right here, that are add up to 180. They're supplementary. These two are equal. So let's do some math. Subtract a 3x from both sides. Okay, I've got the x, so that cancels out. I've got the x on the right-hand side. Let's take this minus 10, get rid of that. So I add a 10 to both sides. Look what I get. That's a 20 equals 4x minus 3x is x. So x equals 20. All right? That's all there is to that. It's not hard, is it? Just the geometry is just understanding that those two angles equal each other. If you know they equal each other, it's not that hard to solve for x. Let's take a look at this. In order for L and M to be parallel to each other, what are these two angles right here? What's the name? Alternate interior. We just finished saying alternate interior angles would be equal to each other, wouldn't they? So if these angles are equal, then these lines would be parallel. again, it's kind of small, but this is 6x plus 4 up here in the top corner. Down here in this corner right here is 8x minus 8. So equals 8x minus 8. Okay, that's all the geometry. You've done the geometry. Now you just have to do a little math and solve for x. Subtract 6x from both sides. Okay, so that cancels out. That's going to be a 2x, right? But now what do? Get rid of the minus 8. We add an 8. And that equals what? 12. And then x equals 6. Divide by 2. There it is. Simple, isn't it? Yeah, absolutely. Again, for like the third time today, the part that you really, I should say the important part, is to realize, are they supplementary or are they equal? All right. The only time they're supplementary is if they're consecutive interior angles. You got it? All right. All the other ones, alternate exterior, alternate interior, if you had corresponding, right, they would all be equal to each other. All right. It's the consecutive interior when they're supplementary. All right. Let's take a look at number 19. Again, it's not real. It's not real sharp here. Let's try to make it a little bit bigger. I don't know if that makes it any better or not, but we'll see. So let's move this. Oh, got all those marks from before. Let me try to get rid of those. There we go. All right, here we go. It says copy the figure on the answer sheet. Okay, so let's copy it. That doesn't have to be exact, but so it kind of looks like this, kind of looks like this. All right. I mean, you just draw it, with a pencil. Let's make it a little bit bigger. Okay. What's it say? Construct the segment that represents the distance indicated. Well, let's put the letters on here. This is A, this is B, and this is C. So the question says from C to line AB. So we're going from C to line AB. And we want to find the distance. What do I find? How do I find the distance from a point to a line? How do I have to draw it? Draw it perpendicular. That's right. Okay, that's the key to this. So start from C, which is right here, and we have to draw it to AB. So do we draw it right there? Do we draw it right here? No, we draw it so that it's what? It's perpendicular. Okay? And then in order to say it's perpendicular, do I just draw that line and say, well, that's it? Right. If that's all you draw right there, if that's all you drew, sorry, then that would be wrong, right? Because it's got to be perpendicular. So you got to draw your little right angle symbol right there. That's all you have to do. That's your answer right there. That little red line and that little right angle box, that's your answer. That's all you have to do for that. It's pretty easy, isn't it? Okay. All right. Let's get rid of that. Whoops. Let's get rid of that and that. All right. Let's draw this one right here. Looks like it goes like this. I know it looks like it's kind of missing the bottom there. It's just weird how I just imported the thing. I don't know why. All right. Anyway, it kind of looks like that, doesn't it? That's D, C, B, and A. What are we trying to draw? We're trying to draw a segment that represents the distance from D. We want to go from D to line AB. All right, let's do this in red again. So we want to start at D, and we want to go to AB. So does that mean I go to here? I go in the middle? Do I go to A? Do I go to B? I got to make it perpendicular, but there's no way I can make it perpendicular. Extend AB. Very good. Okay, so let's do that. Let's take AB. Let's extend it out a little bit. Okay, well, you can extend it out a whole lot of bit if you wanted to. And so we're going from D, where? To that extension of AB, right? So where do we go? Do we go to the end here? No, we go what? Give me a better word. Perpendicular, right. Perpendicular. So we go right there. Is that enough to say that's my answer? You need the right angle. That's right. You need the right angle symbol. Okay? So you need that little right angle symbol. All right? And that's the distance from there to there. And that's all you need. Okay? Make sense? Sometimes when they extend the side out, they put that as a dotted line. That would be fine. I don't care if you make it a straight, a solid line or a dotted line. It doesn't make any difference. As long as you extend that side out and you drop this perpendicular. You see it? Okay. That's it. That's your answer right there. Okay, so that's chapter 3. Well, at least it's 15 to 20. But again, look on the other video. I'll just make this 2 videos, okay? So it's going to be like chapter 3A and chapter 3B. Is that all right? Okay, so we'll close this one out and then we'll start chapter 4, okay?